Hello mate, and welcome back to our Unity Beginner tutorial series. In this episode we're going to carry on working with player controls for our player object. Before I get started, a huge thank you to everyone for subscribing and hitting the notification icon. That really helps me out. And of course an even bigger thank you to my members and patrons. Your names will run across the screen at the end of the video. So let's jump into this then. We come back to our script. We currently have a really simple way of inputting which direction we want our character to move, but I think we can all agree from the last episode that it was incredibly slow and not particularly interesting. So what first thing I'm going to do is I'm actually going to create a public variable. Public means that it can be affected from places outside of this script, and what we're going to call this one is, let's go with movement speed, and I'm going to make this a floating point number, a float. That means it's going to be a number that can have decimal places on it. And I'm going to just give this a speed of, let's just say 3F for now. Nice and simple like that. Add a space in there just to make things a bit simpler. Now if I jump back into Unity, the script's going to update, and what you're going to see now is that movement speed has now become a property that we can adjust from Unity Editor itself inside the player script area, which is quite useful because it means that if we want to just change that variable, we don't have to do it from the script, we can just do it from the Unity editor. And now you understand why having private and public variables is useful, because we don't have the ability to change the previous variable, which was rigid body, because why would we need to change that? But movement speed is something that we want to be able to access from the Unity editor and change it. So now we need to actually apply our movement speed to our script, to our movement speed, and believe it or not, it really is very simple. I'm just going to copy the name of that variable because I can't be bothered to type it again. And what I'm actually going to do is, where we've got vector3 right, I'm actually going to put a multiplication symbol in, and I'm just going to paste movement speed there. And then I'm going to do the same thing for left, because we don't want left to feel left out, pun intended, etc, yada yada yada. And then I'm going to save my script again. So what I've now done is I've actually created a movement speed variable that I can adjust from Unity Editor. And if I run my code now, what you're going to find is it's a little bit quicker. And if I adjust the movement speed, so you have to pause, give myself a movement speed, let's say 5. If I press play again, it's a lot quicker. Much quicker. So there you go. So now we've got a variable that we can adjust from our Unity editor that controls how fast our player moves. Not only can we adjust it from the Unity editor, but we can also access it from other scripts should we require it. You may have noticed when I was doing my test just then that when I let go of the button, it didn't exactly do what it was supposed to do, and I'll just demonstrate this again. If I hold right, you can see it's taking a little while to slow down, which is fine. But if I were to run off the edge, it takes a while before it actually stops and dies. So if we come again, now if I keep holding the button, it doesn't drop. It's basically, gravity isn't affecting it while I'm holding the button down, which is all kinds of wrong. And the reason for that is that we're forcing the vector to be vector3 right. So we're telling the game that the velocity of the object is vector3 right whilst we're holding the button down, which is fine if we're on a surface. But when we're hovering in the air, we don't want to be vector3 right. We want our horizontal movement to be right, but we also want gravity to keep affecting it. So what we actually have to do is, I'm just going to drop that down for a second. We actually need to go new vector3, and then we need to give it some properties. First thing, the X property is going to be movement speed. So movement speed. We want our Y properties to be player rigid body dot velocity dot Y. And we want our Z to be player rigid body dot velocity dot Z. And then we can close that off and we can actually get rid of that altogether. So now what we're doing is we are telling our game to use movement speed as our direction, but we're also telling it that we want our X, Z and Y velocities of the rigid body to be untouched, to be as they are supposed to be. And of course, because we want our other opposite directional motion to be the same, we're going to just copy that and we're going to paste it again. And this time we're going to change our movement speed to minus movement speed so that we're going in the opposite direction. Save our code. And now if we come back to Unity, wait for our script to update, and we hold down our play button. And then if we run off the edge, as you can see, our player falls to his doom. And if we go in the opposite direction, just to check that it works while we're holding down right as well, now you can see that gravity is now impacting the character as it's meant to. And we still have a little bit of momentum when we are moving left and right, which is it's okay for now. However, let's for argument's sake say that that is not acceptable. There's a really simple way of fixing it. So what we're going to do, come back into our class, and inside our update class, we're going to create a local variable. And what we're going to do is call this our target velocity equals vector3 0. End that with there, and then obviously we need to tell the game that this is a vector 3, and this is a local variable, so this is neither public nor private. It's only accessible inside the update class. And what I'm going to do now is I'm actually going to copy this, and I'm actually going to change where we say player rigid body velocity. I'm actually going to change that to read target velocity, and I'm going to do the same thing here, like so. And now what I'm going to do is have player rigid body dot velocity equals target velocity. So what we're doing is we're saying that if we're not pressing a key down, then the velocity is 0. If we are pressing the key down, then it's going to be movement speed in whatever direction we want it to go in on the X, then whatever gravity is doing on the Y axis and the Z axis. And then we're basically doing that. So now what we've done is we've completely removed any acceleration or deceleration from our character. So if I save my script, come back into Unity, let the script update for a moment. Now if I hit play, I have a player that I can control. There's no acceleration or deceleration. It instantly moves in either direction, and it stops as soon as I let go of the button, which is, it's fine, you know. It just means that if I come right to the edge, I can come right up to the edge of the floor and not fall off, rather than having to decelerate and risk slipping off the edge, which can be quite annoying, I suppose. Now that we've got that wrapped up, what I want to do is I want to actually start adding some kind of jump controls. So if we come back into our script, I'm going to create a new public float, and this one's going to be called jump power, with perhaps one less p, jump power, and we're going to give this like a, let's go with 150 F as being our initial value. Nice and simple like that. Now what I want to do is I want to actually use that value for something rather than just being there for decoration. And what I'm going to do is actually I'll just put those spaces in the wrong place, so I'll just remove that down there. After we've created our target velocities X movement, what I want to do is I want to go for another get key down statement. So we'll just grab one of these from there, save having to retype it, pop that there, and then add that there. Let's just get rid of that space there. This time, what I'm going to look for is if we've pressed the space bar or the W key, that's a 2, we don't want that. Let's just come back here and we'll change that to W. Finger is hovering over the right place. Now what we're going to do is we're going to do something slightly different. We're not going to change the velocity. What we're actually going to do is we're going to say player rigid body dot add force. So what we're doing is we're applying a force to our physics engine on our character, on our player character object, which is obviously a player rigid body. We're applying a force to it, and what we're going to do is we're going to apply vector3 dot up, and we're going to multiply that by jump power. that one, jump power, and we're going to close that off with our semicolon, save our code, and then come back into Unity. What you're going to see is it's going to update. Now if we run our code, give it a second, we've got left and right movement, and if I hit the spacebar, as you can see, it's gone mental, and that's because I've actually used an incorrect command. If I come back in here, we remember get key. So because I held the spacebar down for a fraction of a second, but it was enough to rack up several thousand frames or several hundred frames, what I actually need to do is change that command to get key down. Come back to Unity. Now that the command has been updated, now if we hit play, if I hit space, you can see we get a piddly little jump, and if I keep hitting it, it floats up in the air and then gradually drops back down. So it's less than ideal currently, but we can fix that nice and simply. So in order to do this, what we actually have to do is come back into our code just here, and where we're currently checking to see if get key down, we actually need to add some more code here. So what we've got is, first thing we need to do is we're going to use a method called ray casting. And what we're going to do is we're going to cast a ray straight down and see how far away the floor is. Obviously we need to be touching the floor, but we'll come to that in a minute. So the first thing we want to do is create a variable which is going to be of the type raycast hit, and we'll just call it ray hit. That, and we can't, so we will. We're just going to call it hit, nice and simple, like so. Then what we're going to do is we're going to go for another if statement. We need a conditional, so if, and now we're going to introduce something new, which is the physics engine, and we're going to call raycast, and we are going to add our curly braces at the end of that just to clear up that statement like so. Now we need to add some properties inside of our raycast call, otherwise we're just not going to see anything at all. So first thing we need to do is tell it where the ray is going to start. So transform.position. That's our way of telling the game that the player's feet is where the ray will begin. The next property that we need to add is a direction, which is going to be vector 3.down. So that's telling the game which direction the ray needs to move in, straight down. Now we need to tell it where we're going to put the information when we get hit, which is obviously going to be the raycast variable we've just created. So we're going to use the phrase out and then hit. So now it knows, and as you can see, the underline from underneath hit has now disappeared, the little green underline that was there. Just realized that there's a comma there instead of a full stop, which is causing problems. So now we're putting this data into that variable, which is going to make life a little bit simpler. The final property that we need to put into this is the maximum distance of our ray. So what I'm going to do is I'm going to create another public float, and this one's going to be player height, and we're just going to give that a value of 1f. Go. And now what we want to do is just open some brackets here, and we're going to say player height. Nope, that came out wrong. Let's try that again. We want player height multiplied by, no, tell a lie, divided by 2f. And then we're going to multiply that by 1.001f, like so. And then I do believe we require one more set of parentheses, one more bracket there, yeah. So that bracket is closed off there. That's the transform. Perfect. Okay. So the reason we've done this is, jumping back into our code, the ray is cast from the middle of our character, not its feet. So we need the height of the character times by a half, so we're only casting the ray half of the height of the character because it's coming from the middle, and then we're multiplying it by 1.001f because we don't want it to be exactly at the bottom of the character where the ray stops, because if that's the case and the objects have already collided, we may never meet that condition. So 1.001f means that the ray sticks out a tiny little fraction lower than the player's feet to detect whether or not that the character is in fact on the floor. So jumping back into our code, the last thing we need to do is to take this statement that we have previously for our jump, cut that out and paste it into there, and then we can just delete that extra line. In fact, what I'm going to do is I'm actually going to change this from multiplied by 1.001f. I'm actually just going to add that to the final number there. And because RenPy or C# or any other programming language use the BODMAS acronym, I can add that to there without brackets because it's going to do the division before it does the addition. So we should be able to save that, and then we can see what we see. What I'm actually going to do in order to get this all functioning properly, I'm actually going to tidy this code up a little bit because we don't need to actually do that. What we can do instead is just say raycast hit and then just go underscore there like so. Everything in the code is now correct. So if we come back to Unity Engine, just double check that your player height actually reads 2. Mine was reading 1, which was causing me to not be able to jump. So now if we come into our code, you can see because I'm hitting spacebar, it's only letting me jump when I'm on the floor, but my jump power is still really bad. So let's just change that to something like 400. And then let's just run that again. And as you can see, it's allowing me to jump, but not apart from when I'm touching the floor. So as basic as things are, we're in a pretty good place right now. So I hope you found that useful and informative. Let me know what you think in the comments below. I'm sure you will, and I will see you in the next one. But until then, you take damn good care of yourselves, alright? Bye-bye.